Spokojnej noci. This is Russian for good evening, or translation, peaceful night. Today's lesson is going to be 4.2, the case of the missing diagram. So some of you might be scared with this lesson, but hopefully not. The idea of the case of the missing diagram is that you are given an if-then statement and you have to design your own picture to go along with your proof, proving that if-then statement. To set up a problem, there is three things. First, you must draw and label a picture. Second, the if is the given statements. The then part is what you're trying to prove. Understanding that, we should be all right. Let's jump right into the examples. Looks like we have 7 to go through. Example 1, if two altitudes of a triangle are congruent, so we have the if, there's our given, and then our then statement, what we are trying to prove the triangle is isosceles. So if two altitudes of a triangle are congruent, so let's draw ourselves a triangle. Let's call it ADC. It has two altitudes, so maybe I'll make an altitude from here, causing this B, and I'll draw an altitude from here, causing this E. And now we have to write our given statements. So given, we're given that triangle ACD with altitudes DB and CE. We also know that they are congruent, so DB would be congruent to CE. And we are trying to prove the triangle ADC is isosceles. In tonight's lesson, you're not going to prove your pictures, but we will then elaborate after you have the correct pictures to know that you can make the proof of your own, and on a test, an assessment, that you will do that. In number 2, it's not in an if-then form, but the medians of a triangle are congruent if the triangle is equilateral. So where's our if? Here's our if. So this is your given. All right, and then what are we trying to prove? The medians of the triangle are congruent. Jump right in, sit right down. We got F, G, H is my triangle. Make it up, have fun with it. L is here, K is here. Call this point J. What do we have here? We have a triangle, given. Triangle F, G, H is equilateral. What does that mean? All sides are congruent. Nicely done. I heard you. And it has medians. GL, FK, and JH. What are we trying to prove? We are trying to prove that GL is congruent to FK, which is congruent to JH. Number 3, the altitudes to the base of an isosceles triangle bisect the vertex angle. So what do we know? We got the altitude to the base of an isosceles triangle. So we are given an altitude to a base of an isosceles triangle, and we're trying to prove it's going to bisect the vertex angle. Draw it up. Let's have a little fun with it. We got DOG. S. We're given triangle DOG is an isosceles triangle with base, just like you've been seeing, OG. The altitude DS is the altitude. And we are trying to prove that DS bisects angle PMN. That one's probably an easy one to do because you can just prove it. How would you prove this one? These two right here would be congruent. That's an altitude. Take a peek at it from the right angle. If you're standing there, is that side congruent? Ta-da! HL it is. HL, our friend. So we're not swearing. Number 4. If two angles of one triangle are congruent to two angles of another triangle, the remaining pair of angles are also congruent. Well, what do we have here? We have two triangles. So we'll draw one triangle. Let's call it QRS. Now we'll draw another one. TUV. W, X, Y, and Z. Now we know our ABCs. Next time, won't you sing with me? So what do we have? We have two triangles. Given triangle, or given that two angles of one triangle are congruent to two angles of another triangle. Pick two. I don't care. Let's say Q is congruent to V. So angle Q is congruent to angle V. Also given, we'll say angle R is congruent to angle U. And we're trying to prove that angle S is congruent to angle T. See, what makes these proofs great is that if you have the same as the neighbor next to you, the exact same, because you use the exact same letters, probably not going to happen, so don't do it. If two triangles are congruent, in number 5 here, then the pair of corresponding medians are congruent. So here's the given, here's the proof. So what do we have? We have two triangles are congruent. So that's interesting. We're starting out with two triangles. DAB and another triangle, EHF. Those two have to have corresponding medians. So we have a median here, and we have a median here. Given triangle ABD is congruent to triangle EFH. What are we trying to prove? We're trying to prove that AC is congruent to EG. We need a little more work for that one, but we're asking you to prove it right now. Finishing it up, we have 2 left here. Number 6, the angle bisector of the base angle of an isosceles triangle meets to form another isosceles triangle with the base. So what are we starting with? An angle bisector of the base angles of an isosceles triangle. So we're going to start with an isosceles triangle. We'll call it FOX. Fox. Slide Fox. And we know it is isosceles to begin with. So let's just jump into the given and say triangle FOX is isosceles with base OX. What do we have? We have angle bisectors. So we got an angle bisector out of here. We got an angle bisector out of there. Here, there, everywhere, there. They're meeting to form, call it M-Fox. So we also know given is that OM bisects angle FOX and XM bisects angle FXO. Our goal is the other part, form to meet an isosceles triangle. So we're trying to get that triangle MOX, MOX, is isosceles. Pretty solid so far, huh? Hopefully that you stopped, take a moment to look at these, and we're going to do some more in class. But really, I mean, it's a different lesson than we've seen before. The line segment joining the vertex angle of an isosceles triangle to the trisecting points of the base are congruent. Well, all of the beginning part, this is the part where you're trying to prove. And then the other part is the given. So the rest of this line segment stuff here, there's your given. So let's do it. We have our big triangle. Let's call it NPS. The triangle has line segments, it's isosceles, and it's trisecting points. So it has trisecting points down here, R and Q. So this line and this line, trisecting points. So we're given that triangle NPS is isosceles with base SP, R and Q trisect the base, that's SP, and we're trying to prove that NR, the line connecting that, and the line NQ are going to be congruent. And that is our final lesson on, a question I should say, on lesson 4.2. Come in with knowing this, and we'll do a lot more, so we'll hopefully make it easier in class. And as the Russians would say it, nebloha, which means that was not so bad. Good night.